Good morning, good afternoon, and good evening, everyone, depending on when you're watching this and where you're watching this from. Welcome to the third in our High Noon series. We're talking about MySQL high availability with Geo-Scale. And today we're going to be looking at Google Cloud SQL versus Continuent Tungsten clusters. And our goal is to build a Geo-Scale or multi-region, highly available MySQL implementation. And that could be in the cloud, or it could be on-prem, or even hybrid cloud or multi-cloud. My name is Matthew Lang. I'm the Director of Customer Success for the Americas here at Continuent. And a little bit about me, I'll get back to that picture in a second, but I've always been into Linux, MySQL, and cloud. I actually started using Linux in the 90s, and I've been using it for my professional career ever since. I really enjoy working at startups, and I've been fortunate enough to work in several startups where there's been exponential growth in employees and sales, and whether that's in automotive, steel, medical, and now tech industries. So I've done MySQL DBA work. I've been a Linux sysadmin. I've been a site reliability engineer and a cloud architect. And one of the more interesting things that I've done is I made a replication system for a proprietary database. And that's actually still in use at that company. They have not replaced it, even though I am no longer there. And on the weekends, I like to go and play out, do some concerts or something like that. A little hard right now, but hopefully soon we'll all be back out and I'll be able to do my thing again. So a little bit about Continuent before we move on. We are the MySQL availability company. And let me just talk briefly. How do we fit in? Why are we in authority to talk about this? Well, we've been around since 2004. We've seen open source uh, really take on a life of its own, and we've seen cloud computing rise. And we've really been at the forefront of the MySQL market. We've witnessed MySQL become extremely widely deployed, and in the beginning, there really was no high availability solutions for MySQL, let alone any sort of clustering solutions or Geo-Scale solutions. And that's where we come in. Uh, we do high availability, clustering, and Geo-Scale. And again, we've been doing this since 2004. So we're not a huge company. We're not the biggest, and that's really not our goal. Uh, we just want to be the best at this. And again, that's the best at clustering, highly availability, and geo-deployed, highly available MySQL. So maybe you've seen the previous High Noon webinar, but if not, what we want to do is look at several solutions to deploy MySQL at the geo scale and look at highly available solutions. So what we're looking for is rapid failover in the local network so that we have high availability for our applications. We would like to have our applications geographically distributed so that we have low latency data replication with a consolidated view, consolidated management view. Uh, Obviously, we want good performance, fast local response times for our read traffic. Um, and we want to deploy not just at a geo scale, but we want to have active MySQL primaries in multiple regions. So there would be an active database in each region that we deploy in, or each site, each cloud provider, whatever it may be. Of course, if we have an existing application, we really don't want to change the application code. We want to be able to deploy our solution without changing our applications. One other thing, too, is to deploy complex schema changes without taking down our applications. This has traditionally been a challenge, really, with any solution. So we want to see, how can we do that? What solutions are going to allow us to do that? And then also, too, let's try to avoid provider lock-in. If we're locked into one provider, obviously we don't have choice, and it could be really expensive in the long run, in the future for our application. So, and also too, when we're talking about MySQL, we really mean MySQL, MariaDB, and Percona Server in any version. So let's get into the High Noon series. This is a new series where we are comparing other MySQL clustering products to Tungsten Clustering. And we're going to look at a bunch of products. And what we do is we do a deep dive with each product and we rank them and we figure out what features they have, what they don't, and how well each feature works. And we're able to roll them up into kind of a scoring system, right? From 1 to 5 in each of these areas. And when you're looking at a package for an enterprise cluster, these are pretty much, the main features that you're going to be looking for. Continuous operations, right? You want your cluster to be running, your application to be online 24/7. You'll probably want to be able to scale it as well. Hopefully, you're going to have an increase in traffic, increase in business, or more drive to your website. So you want your backend cluster to be able to handle that. Um, are you going to be able to do a geographic deployment, right? Or a geo deployment? Or is it just a single region only? So we'll look at that as well. And then how is the overall performance? Are we going to take a performance hit by putting in a cluster, or are we actually going to be able to improve the performance of our application with our cluster? And then what is our application see when it connects to our cluster? Does it have to be modified? Is there some sort of change that needs to happen? Or can we just install a cluster and our applications are going to work fine? And that's what we mean by transparency. And then, of course, security is always a big issue. And so we'll definitely look at that. And that's something that's coming up more and more. So we definitely want to make sure that all of our products do support good security. And then, of course, once we get this deployed, it might be a complex system. We need a good tool to manage the entire deployment and the entire topology. And with that, too, we need to be able to monitor what's happening within our cluster so we can react if things don't look right. And then lastly, once we have our complete topology, our complete deployment all set up and running, how easy is it to replicate our data out or get our data out and load it into some analytics tool where we can have a look later and run complex analysis on our data? So one other thing too, really important, is support. Um, there are always going to be questions, always going to be issues, or maybe something that you just don't understand. And so, where will you get your support? Some options are online forums, right? Maybe not the best place or the most up to date information. The information in a forum isn't necessarily verified. um, Perhaps it's an email system, right? Where you email support and then the next day you'll get an answer and you'll reply to that and wait another day for an answer. Or maybe you actually get a live person, an engineer with experience. That's obviously worth a whole lot more because you can get your questions answered much more quickly and get it directly from the source. So we'll see how all these solutions compare with support. And then, of course, we talk about intangibles, right? We're clustering MySQL. So, what versions of MySQL do we support, right? Or which ones does a particular solution not support? So, that's also important if you need certain features in a certain version of MySQL. And when we say MySQL, that could be MySQL Enterprise, MariaDB, Percona, any one of those variants. Platform's important. Are you going to be deploying in the cloud, hybrid cloud, maybe on site? So whatever solution we pick has to support our target deployment. And then product maturity, I think that goes without saying. The more mature a product, the more time it has to have bugs worked out and features put in as well. And then with all this said and done, what's the total cost of ownership, right? And how much does the physical software or all the pieces cost? But also, what about support? And what about man hours and learning the product? And really time spent on implementation, right? And that's what we call total cost of ownership. And then lastly, what we'll be looking at are the various use cases. So we see right here, we can have a quick look. We have pretty good support for HA. Each product handles it a little differently, some better than others. And we'll look at how they handle HA. DR, or disaster recovery, not everyone supports that, but it might be something that you need. You may want to avoid a catastrophic situation in a particular region, and you may need to fail over to another region or another site. Zero downtime maintenance is also important. And I think every DBA has gone through this where there has to be some major maintenance. How is that going to impact the application? Or does it even impact the application at all? And again, that flows with continuous operations, right? We need our application to be up, especially for large enterprise applications. We can't afford downtime. And that includes maintenance. Okay, and then what about some other features like having multiple primaries? Is that something that we want to have? How about a geo-deployed active passive cluster? So we can fail over, and we can also fail back, and we can leverage the DR site maybe for reads. Getting even more complex active clusters, right? Deploy a Geo-Scale topology where you have multiple active clusters and all replicating to each other and all in sync. And this goes, again, leads into Geo-Scale clusters, right? Can we deploy globally and have our applications close to our end users? So that's kind of the overview. Let's get into it now. So on to Google Cloud SQL. Actually, Google Cloud SQL has a version for MySQL and Postgres. Obviously, we'll be looking at the MySQL version. And some of the characteristics of Google Cloud SQL. This is a managed deployment of MySQL database within Google Cloud, right? So all the major cloud providers have their own version of a managed database. It's got really flexible point and click backups, right? Easy to take a backup, and it can do automated daily backups. By default, you get 7 days worth of backups, but you can change that and retain up to 365 daily backups. You can do backups on demand, and you can also do point in time backups, right? So you can restore a backup from a particular point in time to a new instance. So not the same instance, but a new instance. Again, it also does automatic failover as long as you have a failover instance provisioned. You can provision up to 10 read replicas. So your write traffic could go to those read replicas. There is a basic proxy available. It's fairly new, and it's an additional charge. Again, it's pretty basic, but it does exist within the Google Cloud ecosystem. It does support encryption of in-flight traffic, as well as traffic at rest. That's a great feature, and it'll automatically do storage increases up to 30 terabytes, or to a limit that you specify. And let's look at the replication within Google Cloud SQL. How does that work? Well, in the first instance, you have what's called a failover instance. And this is a special instance that you can have one of, and it simply acts as a failover candidate. So this is what gives the Cloud SQL high availability. It's this special failover instance. It can't be used for anything else. It's a dedicated failover instance. It can't be used for reads or anything at all. It is kept in sync using synchronous replication. So we can be fairly certain that it's going to be up to date in the event of a failover. And it's priced the same as a primary instance. So in this case, if you build a high availability instance, it's going to be charged twice as much, right? One for the primary instance, one for the failover instance. And then you have read replicas. These are different. You can provision up to 10 of these, and these can be used for reads, but they are not used for automatic failover. They are going to require binary logging to be enabled on the primary, right? And that's how you would leverage, for instance, native MySQL to enable binary logging. So with this in mind, they don't come out and say it, but it appears to be asynchronous replication. And again, it's priced the same as a standalone MySQL instance. So if you have, let's say, one primary, one failover instance, and two read replicas, you'll be paying 4 times the price of a single instance. And you connect to a read replica using its IP address. Each read replica is going to have a different IP address, and that's how you would connect to it based on IP address. And something new that was just introduced is what's called a cross-region read replica. And it works almost exactly like a read replica, but it's located in another region from the primary. You can deploy several of these if you like, have a primary in one region, and then let's say 2 cross-region replicas in 2 other regions. Again, it's going to be priced the same as the primary instance. So the read replica in a different region is going to be priced the same as that primary instance. So again, we're talking about geo deployments. So if we want to do a geo deployment with Google Cloud SQL, what's required? Well, if we were doing this webinar, say 6 months ago, we would say, well, we really couldn't do it. But now, since June of 2020, we do have the cross-region read replica. So we can have a read-only replica in another region. How would we do this? Well, first, obviously, we need a primary instance. And then we have to make sure automatic backups are enabled. This is a requirement for a read replica. We must enable binary logging on the primary instance. Again, this is another requirement for read replicas. When we enable binary logging, the instance will restart, so your database will go down. So this is something that must be planned ahead of time because you'll need a maintenance window. After enabling binary logging, we need to perform a backup of the primary instance. And then from there, it gets a little easier on the Cloud SQL instant page. We're going to select Read Replica and then choose Create Read Replica. You can't create a replica of a replica, but what you can do is promote a read replica. And this is how we would do DR in Google Cloud SQL. We would take the replica, whether it's local or remote, and then choose Promote Replica. So now this replica becomes a primary and it's a standalone instance, right? It's not connected to any other read replicas. It's its own instance. So if we want read replicas with this newly promoted replica, we need to create them with the steps above. So that's how we would do DR with Google Cloud SQL. We would leverage the cross-site read replicas. So in this situation, what are some of the limitations? Well, if we're doing high availability, some write-intensive workloads may suffer in performance because of synchronous replication. Synchronous replication can have an impact on the application, and it takes a little longer at times to commit a transaction when we're using synchronous replication. And this is because we must wait for an acknowledgement from the replica to say, I've got this transaction before we can return control back to our app. So a lot of writes could slow down our application. We only have a single failover candidate in the cluster. So not only can we not use that for reads or really anything, but if the primary and this failover candidate somehow go away, we're kind of stuck, right? We can't define multiple failover candidates. So we really just have 2. That's it, the primary and the failover replica. Cross-region support is pretty limited. Again, it's something that's new, and it's just really a simple replication from primary to the secondary in the other site. Now, we do have a proxy. It's very basic. It also there's a cost for that, so it's not free. And if we have a failover, all connections are terminated during a failover. So our application is going to get disconnected from the database during a failover. With certain apps, that's going to be catastrophic, and it could potentially show an error message to your end users, which is really not what we desire. So when we fail over to a cross-region replica, if we want to provision other regions now, they all have to be reprovisioned, right? Because now the new primary, which used to be a replica, is its standalone instance, right? There are no other replicas connected to it. And the pricing, although it's simple to figure out, if you use, say, 5 times more instances, you pay 5 times more. It's simply linear pricing. And that could get pretty expensive if you have a lot of clusters to deploy. If we want to take over or take advantage of the read replicas, our applications have to be aware of who is the primary and which one is the read replicas. And there's extra logic that needs to be put in there to take advantage of the read replicas. And if we have a lot of read replicas, we want to kind of load balance between them all. Again, that's additional logic that we need to program. And database maintenance and schema changes are going to cause application outages, especially large schema changes where we have to, say, do a table rebuild. Really, the application could be offline for hours, and that's really not something that we want to do. And as a DBA, we all spent countless hours just waiting for these schema changes to complete, and our application is down the whole time. So how do we approach building a better MySQL Geo-Scale solution? Well, here at Continuent, we have our proven solution, Tungsten Clustering, right? This provides continuous MySQL operations, so highly available, uh, zero downtime maintenance, so we can do OS patching, MySQL patching, maybe upgrading to the latest version with no downtime. We fully support geo-distributed MySQL clusters, and we accelerate on that, and we'll see that in a few minutes. And along those lines, we support cloud, multi-cloud, or hybrid cloud. So you can deploy in 2 cloud providers if you would like, or deploy in a cloud and on-prem at a geo-scale. Okay. Included is the Tungsten connector, which is an intelligent proxy for MySQL. It speaks to MySQL protocol, and it can handle read-write splitting automatically, so no changes to your application. Or if you have this functionality in your application, great, we can leverage it. And we support MySQL off the shelf. No changes to your application. Just use whatever MySQL version you'd like. And of course, as I mentioned, that includes MariaDB and Percona Server. Let's have a look at what we call active passive clustering, right? So we can scale a cluster to multiple regions, multiple data centers, or multiple clouds, or a combination of all of that. And we really don't care if it's what cloud provider you use, if you're going to deploy it on a VM or directly on the servers. We run on really anything. Uh, and this particular topology is active passive, which means there's one site, one single site that is active and has a primary, which is a read and write database. And then all other sites are replicated from that primary cluster. And we can manage this cluster from any node within the cluster. And we can also fail over or move the primary from one site to another site. So if we have, say, in one region, maybe an outage, or we're going to be doing some maintenance on that region, we just fail over and activate the other region to become active. And then when the first region comes back online, it catches up with replication and gets added back in the cluster. And we can switch back or fail back with a single command. So just another kind of contrast. This is active clustering. And really, Continuent is the only one doing this right now. So this is where, again, multiple clouds, data centers, whatever hardware, but all clusters are active. So each active cluster has a primary that you can read and write from. And with this, you can deploy your clusters close to your users so they get the best performance. Your local users can read and write to a local database. But all these clusters are in sync with each other, and each one is active. And in a failover situation or a failure of a single site, we just redirect the traffic to another site within the cluster, and we're good to go. Again, everything is replicated between each other. And if that failed site, when it comes back online, we just add it back into the cluster and replication catches up automatically. How about, we mentioned zero downtime maintenance. Uh, how would we do that? Well, let's say we wanted to upgrade MySQL. So one thing with tungsten clustering is you can mix MySQL versions, which within the cluster, and we fully support this. And this is really an avenue of when you want to upgrade MySQL. You can take a replica, remove it from the cluster. We call it shun. Go ahead and upgrade MySQL and return the cluster, return the node back to the cluster. And we're good. Replication catches back up. And if for some reason there's an error, we can just discard that node and reprovision it in a couple steps. But assuming most MySQL upgrades do go pretty smoothly, now our replica is upgraded. So we repeat that process for the other replicas and our cluster until finally our primary now is on the old version, but all the replicas are on the new version. So we do a command, we just do a switch. That promotes a replica to primary and the primary to a replica. So now on the old primary, we upgrade MySQL and we're all done. No downtime and application is up. And really, this all happens in the background. And when we talk about transparency, no one notices because this is all happening in the background, leveraging tungsten clustering to allow zero downtime maintenance. Let's get back now to the comparison of tungsten clustering versus Google Cloud SQL. Overall features and benefits, for instance, zero downtime maintenance, right? Tungsten clustering, yeah, that's one of our specialties. We handle zero downtime maintenance, as we saw earlier in this webinar. With Google Cloud SQL, any sort of maintenance is going to require a maintenance window, and therefore you're going to experience downtime. With high availability, both solutions do provide high availability. They're handled a little bit differently. Tungsten clustering has automatic failover, and you can fail over to one or more of the secondaries. With Google Cloud SQL, you have a single failover node, a single candidate, and it could take 60 seconds. So that is really kind of a long time when we're thinking about, is our application up or down? Now some of the kind of multi-region topologies. So can we have a DR cluster, active, passive, right? Tungsten clustering, yes, we have automatic site level switch with a simple command that we call failover. We can easily fail over and fail back between sites. With Google Cloud SQL, yes, we can fail over to another site. It's a simple MySQL replication. And then we're in a position where we have a standalone cluster in that region. How about having active? So we have an active cluster in multiple regions. With tungsten clustering, yes, and we can just simply repoint our apps to the cluster in another region, and that's our DR. It's really quick and really simple because both clusters, or however many clusters there are deployed, they're all active, all ready to take read and write traffic. Uh, active topologies are not supported in Google Cloud. How about failback? If we want to fail back after we fail over, that is definitely supported within Tungsten Clustering. Again, a single command to fail back to your original region. Google Cloud SQL, that's not supported. The failback mechanism there would be to enable binary logging on the newly promoted node, which again is going to cause some downtime. And then we can provision another cross-region read replica in another region and then promote that. And once we promote that, now we have to recreate all of our other cross-region replicas. So it's a little messy. Backup and recovery, both utilize existing tools. Google Cloud SQL has managed backups, which are pretty convenient. And now on to scalability and read replicas. Both have read replicas. With Tungsten Clustering, read replicas and failover candidates, they're really the same. So you can define a bunch of replicas, and they could be failover candidates and also be read replicas at the same time. Google Cloud SQL does support read replicas, but to take advantage of them, you're going to have to do something in your app or maybe get a third-party proxy to try to load balance over them. Physical location scalability. Tungsten Clustering features on-prem, multi-cloud, hybrid cloud, really deploy anywhere you want to. Obviously, Google Cloud SQL is going to be available in Google Cloud only. Instance sizing, again, both have flexible instance sizing. With Google Cloud, because it's within their ecosystem, you can choose your instance sizing within Google Cloud. With Tungsten Clustering, you have some flexibility because you can deploy in Google Cloud or any other cloud provider or on-prem and just spec each instance to whatever you'd like it to be. Auto scale, there's really no auto scale in Google Cloud. That would incur some downtime. With Tungsten Clustering, that would be a manual step. It would not incur any downtime. And then again, cluster scaling. When we talk about software as a service architecture or pod architecture, it's really ideal for Tungsten Clustering. With Google Cloud SQL, our scaling really involves adding read replicas, but we still just have one standby replica that can be used as a failover candidate. And at the geographic level, Tungsten Clustering, can we add read replicas and scale over regions? Yes, we can scale across regions, availability zones, and even other clouds or on-prem. Google Cloud is going to allow us just to have simple replication from one region to another. How about active clusters, right? Can we deploy multiple active clusters in multiple regions or multiple cloud providers and have them all active, taking read-write traffic and replicating between each other? With Tungsten Clustering, yes, that's exactly what we do. With Google Cloud, that's not supported. Not surprising, because really Tungsten Clustering is the only MySQL clustering solution that provides active geoclusters. Active-passive geoclusters, again, supported in Tungsten Clustering. With Google Cloud, it's not really part of the cluster. It's simple replication to another region. Other features and benefits, one that we call Smart Scale, right? So this is with the Tungsten proxy. It supports automatic read-write splitting, so it can direct your reads to a read replica automatically, right? Without any application changes. Google Cloud provides a very basic proxy. It's an additional cost, and it's really just used for failover to repoint the apps when the new primary comes back online. And from that load balancing, we can load balance reads with a bunch of different algorithms over our read replicas. So we add more read replicas, load balance between them, and that takes performance load off of our primary, for instance. So that's fully supported in Tungsten clustering using the Tungsten proxy. Google Cloud SQL, again, it's going to require a different proxy, changes to your apps, or some other load balancing mechanism. Up-to-date read replicas, again, Tungsten clustering is going to be using asynchronous replication. Google Cloud actually has a mix here because their failover candidate is synchronous, but the read replica mechanism appears to be asynchronous. And then again, overall database performance. With Tungsten clustering, you're using off-the-shelf MySQL, MariaDB, or Percona Server, whichever you'd like, and you just tune it as normal like you're used to. Asynchronous replication means that there's no performance penalty or no performance overhead for any writes. Google Cloud SQL, when it's using synchronous replication, that could provide a performance penalty. So your applications could slow down if they're really write intensive. And again, transparency. Tungsten clustering requires no applications. It's a bolt-on solution that works right out of the box. For Google Cloud SQL, you'll get simple failover really without modifying your application, but that's it. And your application will get disconnected from your database if you're using the Google MySQL proxy. How about MySQL versions? Tungsten clustering supports really any MySQL version. You can even mix and match versions within your cluster if you'd like. Google Cloud SQL currently supports MySQL 5.6, 5.7, and 8.0. So it does not really incorporate any of the changes, for instance, in MariaDB. And then compatible with all database engines. Really, both support almost all database engines. Tungsten clustering supports all database engines. Google Cloud doesn't support memory or federated. Those really aren't that really widely deployed anymore. Really important, security. How do these solutions handle security? Both solutions can handle security, encryption at rest. With Google Cloud, it's automatic. With Tungsten clustering, you can just simply use any existing technology that you would like to secure your file systems. And it's not going to be a problem for Tungsten clustering. Again, it's a bolt-on solution. Security and encryption in flight, it's available for Tungsten clustering, no problem. Google Cloud SQL also supports that. And so along with security, what about compliance? Are these compliant to work in environments like PCI or HIPAA? With Tungsten clustering, yes, and with Google Cloud, yes. And that's really important for a lot of applications, for instance, credit card processing, or maybe protected health information. What other features and benefits? Management and monitoring. Deployment, both are easy to deploy, point and click. Cluster management. Tungsten clustering has Tungsten Dashboard, so it can be managed via a GUI. It can also be managed via the command line and scripted. Google Cloud SQL is a very simple GUI. It also has an API, which is not quite as simple, but the GUI is pretty simple and easy to use. Monitoring. Tungsten clustering, again, with the dashboard, we can monitor via Prometheus, as well as more traditional tools like Zabbix and Nagios. And the GUI provides monitoring. Google Cloud SQL does provide easy to use and basic monitoring as well. How about alerting and notifications? Tungsten clustering, again, can integrate with notification systems really easily out of the box. Google Cloud, it can be done, but there's some effort to setting that up and to configure it using a centralized tool. And then OS and DB patching, Tungsten clustering, we're pretty good at that, right? We can assist that with scripts, and we can do it all without any downtime. Google Cloud SQL will automatically patch the database. However, it's going to cause an interruption and take your application down. Another thing that we should look at is real-time data replication and an analysis, right? Because if we have all of our data and MySQL clusters, and maybe we have a pod architecture, multiple clusters. What if we want to run analytics on that data? So how do these solutions handle that? So replication into analytics, Tungsten Clustering handles that by using the Tungsten Replicator, right? And it replicates into Redshift, Hadoop, Vertica, and a number of other targets out there. With Google Cloud SQL, you're kind of stuck with basic MySQL replication, and that's going to be manual to try to massage your data and get it into your data lake. How about filtering? So when we do replication, we would want to filter out tables or maybe make some slight transformations in the data. Tungsten clustering handles that. It does complex filtering, both schema level and data level. Google Cloud SQL, only basic MySQL replication is supported, so it's really limited as far as filtering. Cluster aware. The Tungsten Replicator is completely Tungsten cluster aware. So even if there's a failover or a loss of node in the cluster, that replication stream is not going to be interrupted because the Tungsten Replicator knows that there's something, an event that's happened in the cluster, and it knows where to find the replication data, and it stays online. With Google Cloud SQL, it really doesn't support that because it's just basic MySQL native replication. So one important factor that we touched on before is support. So at Tungsten, we're pretty proud that we have 100% customer satisfaction with our support, and our support's 24/7 included. With Google Cloud SQL, you get really basic support, but if you want any sort of enterprise support, it gets really expensive. It's not included. Fast response time, we average less than 3 minutes for an urgent support request. So if you have an issue or you're worried that your system's down or anything, you know that you can get a hold of an engineer at Continuent, and they're probably going to respond within 3 minutes. With Google Cloud SQL, it's a really high additional support fee to get that sort of enterprise level support. And at Continuent, the support team experience, each one of us has at least 20 years experience, either being a DBA, site reliability, or admin, or a combination of the above. And we're quite proud of that, and we're always willing to share our experiences. At Google Cloud, it's really unknown who's going to be providing your first level support. And then overall version support, right? At Continuent, we support all versions of MySQL, MariaDB, and Percona Server up to version 8.0. Google Cloud supports MySQL 5.6, 5.7, and 8.0, which are the most popular versions. Again, we support MySQL Enterprise, we support MariaDB, we support Percona Server. Google Cloud does not support these things. It just supports MySQL in those 3 versions. Deployment, again, Tungsten clustering can be deployed on-premise. It can be deployed in any cloud. It can be deployed in multi-cloud, so having clusters span clouds. And then hybrid cloud, right? It can be deployed on-prem and span into a cloud or clouds. Obviously, with Google Cloud SQL, being that it's a Google offering, you can only deploy it in Google Cloud. You cannot deploy it, obviously, in another cloud or on-prem. And then what about maturity and completeness? Tungsten clustering includes everything you need for HADR and Geo-Scale, right? It has a management piece, which is like orchestration, replication, right? It provides failover, and it includes Tungsten Proxy, which is extremely helpful and extremely powerful. Again, comes with all the components you need, and it's been tested and vetted for years. We have customers running billions of dollars in our clustering solution. Uh, with Google Cloud SQL, so it's really kind of primary, secondary, what they used to call master slave. And it comes with a couple components, but each one is pretty light. So the replication is pretty light, the failover is pretty light, and the proxy is pretty basic. As far as it being fully tested, it's only been around for a couple years. And the cross-region read replica has really only been around for 6 months. How about pricing? Well, with tungsten clustering, it's simply priced per node, but we don't really care about the size of the node. So you can pick the biggest node that you want, and it's still not going to raise the price of the software, right? And we kind of give you the freedom to deploy what you want or what you need, and then uh, we come around and maybe do a true up at the end of the subscription cycle. But the 24/7 support is included. And really, you don't need a whole lot of DBAs. A small number of DBAs can handle a large number of clusters, and we have plenty of customers doing that. With Google Cloud, the pricing is based on the instance size. So if you choose a larger instance size, it's going to cost more. 24/7 support is available, but it's at an extremely high cost for enterprise support. And you'll still need DBAs working with Google Cloud. Even though it's managed, there are still items and maintenance that you have to do that require DBAs. And then in general, really about all the use cases that are supported here. MySQL HA, both support it, right? MySQL DR, Tungsten Clustering supports DR out of the box. Google Cloud SQL, it's a little messy. It's complicated. But now, as of June, it looks like they're doing some sort of replication into other regions. Uh, Complete downtime maintenance, zero downtime maintenance. That's one thing that we offer. Google Cloud does not offer that. You will have to take maintenance windows and bring your applications down. Continuous operations, yes, tungsten clustering, because we do zero downtime maintenance and HA. And Google Cloud, for the most part, we can say continuous operations is supported. They do have automatic failover. But some of the more complex topologies, MySQL, whenever we do any sort of Geo-Scale topologies, multiple primaries, active clusters, passive clusters, and really clusters at the Geo-Scale, that's all included in Tungsten clustering. That's all supported and baked into the product. Google Cloud SQL does not support this at all. So I've spoken about continuent solutions. Let's talk about our products just at a glance. We really have three main products, Tungsten Clustering, Replicator, and Dashboard. Uh, Tungsten Clustering, this is what we've talked about, right? Continuous MySQL operations, zero downtime maintenance. We deploy Geo-Scale. We deploy using multi-cloud or hybrid cloud technologies. We include an intelligent proxy that does automatic read-write splitting. And we support any version of MySQL. And again, that's MariaDB or Percona without any changes to your applications. So I've talked about our customer service and our support. Again, we have a 1 hour SLA for urgent cases. Those cases we track very closely. We end up really less than 3 minutes for our initial response. So that's why our customers are able to measure their uptime really in years. And um, we all have experience with cloud technologies, Linux, systems administrations, and site reliability engineering. Uh, so how does this translate into cost savings? Well, first of all, use whatever MySQL that you're used to using, right? If you want to use the free open source MySQL, that's fine. We fully support that. Um, you can choose which cloud environment you want to use, because we run on any cloud environment. So if you get a deal with a particular cloud provider, feel free to use it. We run in any cloud provider. So that's one way as well that this optimizes your costs. And of course, downtime uh, can be looked at as a major expense. So we eliminate the risk for downtime and those costs. And that includes your maintenance operations. And DBAs can spend more time doing, what DBAs should be doing, improving the performance, rewriting queries, um, doing architecture, instead of, really menial activities like admin and recovery. So again, continuous MySQL operations. So we do HA. We've been doing this for 15 years, and our failover is immediate. So there's not an interruption to your business. And your MySQL recovery time now, if there is, any sort of catastrophic event, could be reduced to seconds, right? And our dashboard provides a graphical view and maintenance tool for all clusters, whether they're geo-distributed or not. And we'll look at that in a second too. With zero downtime MySQL, we can do site level and cross-site failover really quickly, right? This keeps your applications online and it keeps them from being disconnected as well. And that's because of the uh, Tungsten connector. This is great also for upgrading hardware, software, doing any OS patches, again, without taking your applications offline. And we're fully MySQL compatible, well, because we're using real MySQL underneath, and it's really whatever MySQL flavor you would like to use. Of course, one of our big strengths is the Geo-Scale MySQL. We can load balance MySQL read operations across multiple replicas. We can use replicas locally. We can use replicas deployed on a global level so that applications can read from a local replica. Again, geo-distributed MySQL clusters bring your data closer to your application users for better performance and faster response times. And you can add MySQL clusters for scaling. You can add MySQL nodes too, as well, if you want to do scaling that way to add more replicas for better response times for your reads. Uh, because we are agnostic when it comes to cloud or whatever sort of hardware is underneath, you could deploy in the cloud, you can deploy in VMs, you can deploy on-prem. You can mix and match clusters as well. You can have a geo-deployed cluster with one site, say in Amazon, one site in Google Cloud, and another site on-prem. It really doesn't matter. But you can also fail over and fail back from these different private and public clouds or whatever platform you're using. Um, and obviously, if a node or a provider or any sort of regional failure happens, it's easy to fail over to another site or another provider. Tungsten clustering includes an intelligent MySQL proxy that we call the Tungsten connector. And it really has a lot of features, but the important feature that we want to point out, at least in this context, is that it's traffic routing. It will route to a local primary. So if we have multiple primaries deployed in different sites, it'll route to the local primary, and it can route read applications or read queries to local read replicas. And during any sort of failover event or switch event, applications are not disconnected. So your users still have a good experience even when a failover happens. And we can do kind of really cool replication with filtering, transforms in flight. Uh, if you want to use, say, replication to a non-MySQL target, we can do that. So you don't need ETL anymore. You can do real-time replication right into your analytics, and your analytics is up to date at all times. Um, and with the Tungsten Replicator, there's no charge for the amount of data or CPUs. It's just a pipeline. And we just replicate all the data from your cluster or your MySQL source to whatever target you choose. Again, this is a bolt-on application, so it's fully MySQL supported. We can use any sort of MySQL that you want, any flavor, no changes to your application. Just deploy and configure your MySQL cluster, and it's minutes. You use the same MySQL that you're familiar with. So whatever version that is that you want to use, that's what you can use. And there's no difference in your MySQL configuration. We do support SSL, which is extremely important. SSL for all in-flight traffic. So that could be your queries, replication traffic, or even the internal cluster communications, all SSL with encryption. And of course, native MySQL support. Another product too, we haven't really talked about it much, so I'll just go over it really quickly, is the Tungsten Replicator, right? And that allows us to replicate from MySQL to a bunch of targets, right? Again, we can actually replicate to Aurora or RDS, but more importantly, Redshift and analytic targets, right? Vertica, Hadoop, Kafka, there's a bunch, Cassandra, Elasticsearch, and this is really useful for multiple clusters. So for instance, if you have multiple MySQL clusters deployed and you need all the data and all these clusters to be merged into a single target, like say a Hadoop target or Vertica, the Tungsten Replicator can handle that for you. And it'll do all kinds of complex filtering. So typically when you're running analytics, you don't really need every single piece of data, right? Especially blob data. We can filter that out for you. So just the data that you need to get into your analytics gets replicated to your analytics. It's really flexible. There's a whole lot of filters that you can do and transformations of your data as well. And if you want to give it a shot, it's available actually as an AMI in the Amazon Marketplace. You could fire it up and it'll prompt you with the sources, targets, and it'll happily go along. So feel free to try it. Uh, One other target, just our product, just really quickly, uh, Tungsten Dashboard. This is our GUI management tool for Tungsten clustering. So with this, you see your entire cluster. Even if it's geo deployed, you see all sites on a single page. You don't have to jump around between different sites. And you can do all your maintenance here. You can see our global transaction ID, the replication progress. You can switch a primary and a replica to promote a replica to primary. You can do failovers, and it also does monitoring as well. So this is a really powerful tool. And if you're using Tungsten clustering, it'll manage all of your clusters, again, on one single pane. And the best thing is it's included with Tungsten clustering. So you don't even have to pay extra for it. All the monitoring and everything is included. So if I can just talk about Continuent as a company real quickly. Again, we've been around for a while. It's been over 15 years already. And we only have experts here. Everyone is an expert on replication, databases, site reliability. Our support team, again, same sort of experience. Everyone on the support team has at least 20 years of database and high reliability experience. And that allows us to effectively respond to our customers' needs, questions, or even just to chat about architecture or technology. And of course, we're extremely proud that an urgent case, we typically respond in less than 3 minutes. That is our average response time, less than 3 minutes. So that's another reason why our customers stick with us, because they know if they have an issue or a question even, they can get a hold of us. So here are some of our customers. And these customers have been with us for a long time, and it spans a lot of different industries: the medical industry, uh, finance, technology, telecommunications, and gaming, as well as some other industries. So we're pretty well represented in the enterprise space and software as a service space. And why do they choose Continuent, or why did they? Well, we've on all of our surveys, we have 100% customer satisfaction rate, and that is our goal. We're constantly thinking about our customers, and we want that 100% customer satisfaction, and that's what we work for. Uh, Renewal rate, again, 97.5, and multi-year renewals. And of course, companies get bought out, and they may have to adopt different technologies. They may even go off of MySQL. And so that would account for like the 2.5% that don't renew, but that's a pretty small percentage, and it's usually due to a buyout. Again, average response time less than 3 minutes for urgent case, and that helps fuel the 100% customer satisfaction rate. And our average customer has been with us for 7 years, so we do value a long-term partnership. That's another thing that we work for, is that long-term partnership. We're not looking to, for a 6-month commitment and then say our goodbyes. And just some interesting facts. So we're the MySQL availability company, established in 2004. And I've mentioned some of the industries that are represented with our software. Um, but a couple interesting things. In 2014, we were actually acquired by VMware, and we were going to build the database as a service for vCloud Air, which was VMware's cloud offering solution. Uh, Unfortunately, VMware, or maybe fortunately, but VMware abandoned their vCloud Air, and so with that, Continuent broke away and became independent again from VMware. So it was kind of interesting being selected to work with VMware. So that's a pretty big company, a pretty big player in the space, and we were quite glad to work with them. But now we're back on our own, and we decided to release some hardened security features in 2017, which is critical, especially in the cloud space. And in 2018, again, even more changes and more improvements to our multi-site clustering uh, offerings. And we saw our first 10-year anniversary this year. And now in the future, feature is cloud. So stay tuned for Tungsten Cloud. Anyway, thanks so much for listening. Again, my name is Matthew Lang, and there's my email address. Any questions, or you just want to chat about tech or anything else, feel free to drop me a line. Would love to talk to you. Have a great rest of your day, and make sure you see the rest of the High Noon series. Thank you.